So the radius of a circular disc is given as 24 centimeters with a maximum error and measurement of 0.2 centimeters. What do you think those two numbers represent for us? What is the 24? That is the A value, right? Because that's what we were, sorry. That's what we were told the measure was, right? And we were off by how much, possibly? 0.2. So this is A, and this must be what? dx. That's how much we're off by in that measure. My function, we need f, right? Because it's still going to come down to that dy. Your formula for dy is the same formula as it was before. This is kind of the basic formula, is that it's f prime of x dx, right? That's what we're finding here. Our function f, in this case, I think we'll call it a, right, for the area. So it's the area function that we're trying to figure out what the error is in. I didn't read that part. Maybe you don't even know that yet. But yeah, so part A says use differentials to estimate the maximum error in the calculated area. So therefore, the function that we're trying to measure the error in is the area function for a circle. So our f, the f that we're going to use is, we're going to call it a. So let's let, for part A of x, or just simply a equal to pi r squared. That is like our f. That's like f in this definition. And r is like our x, right? So what's the differential? So first of all, let's write something here. So let's say delta A is the max error, the actual max error. So therefore, dA is going to be approximately, what do we approximate the dA, the delta? We approximate delta y by what? dy. So we're going to approximate delta A with dA. Yes. Oops. And so now we just compute the differential. So in this case, what is dA? We take the derivative of that function a. So if I take the derivative of a with respect to r, that's going to be 2 pi r times dr. Yes. So 2 pi r dr. So this would be that f prime of r, or f prime, this first piece, and then dr. All right, now let's put in the numbers. So it's 2 pi times r. R is like the a. 24, good. And dr is our 0.2. So we get 1/5. Is that 48 pi over 5 centimeters squared? So if we approximate that to the nearest, let's see what it is. 48 pi divided by 5, 30.16. So approximately 30.2 centimeters squared. So does that seem like a lot? So it's possible that we're off by 30.2 centimeters squared. So if we're off by 0.2 in the measurement, the max that we can be off with the actual area is 30.2 centimeters squared. Does that seem like a lot to be off by? See, it all matters on what the actual object is, right? Or how big it actually is. I mean, let's say if it's 30.2 centimeters of this entire wall, That's not a lot. But if it's 30.2 centimeters of what, a small piece, that's a lot, right? So to see exactly how big of an error this is, we look at the relative error. So the relative error is going to be the error divided by the actual area. So relative error, part B. The formula is the max error that we calculated, so actual, and then the true. This is going to be the true relative error. So delta A divided by A. So the max error divided by the area. We can approximate that relative error by looking at dA instead, just like we approximated the delta A. dA we said was 2 pi r dr, right? The dA, that's what we calculated up here. Yeah. And then A is your area, pi r squared. If you reduce that fraction down, the pi's will cancel. You can cancel one of the r's in the denominator. You'll get 2 times dr over r. Now, put in your numbers. So 2 times dr is 0.2. R was 24. So that's going to be 0.4 divided by 24. Yeah, so for this, 0.016 bar, right? That's how much of an error it is. That's the decimal, right? That's the fraction of the true, how much we're off by. Does that seem like a lot? No, now it makes, it's more clear, like, oh, it seemed like a big error, but in fact, it really isn't, right? It's only 0.02. Right? So that's what the relative error gives you. How big of an error is this really, right? And then the percentage error, the last part of that percentage error is just convert the relative error to a percentage. So in this case, it would be 1.6, approximately 1.6%.